house robbers. So to solve this problem, we need to know one concept, and that's DP. So DP stands for dynamic programming, and it's all about solving complex problems with simpler subproblems. And to illustrate this idea, we're going to see the problem. So the problem statement says that we are a robber and we have to rob houses. The only criteria is that we cannot rob adjacent houses. And given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So think about what it means to, first of all, rob the houses, right? So 1, 2, 3, 1. So basically you realize that there's only really one way for it. It's like we either can alternate by skipping 1 and then repeating this pattern ad infinitum, or we can start at 2 and then go to 1 and etc. But which route is the best? So to do that, let's first understand how we can rob the first house effectively. The maximum amount of money we can rob from the first house is just 1. What about we just want to rob the first 2 houses? Well, if we just consider these 2 houses, then the most we can rob is 2. We only rob house 2 instead of 1. So that's what DP is, right? DP tells us the most amount of money we can rob if we only consider houses up to that point. So up to, for the first house, we can rob at most $1. And if we want to rob the first 2 houses, then we can get at most $2. So what about for the first 3 houses? Well, there's only 2 ways, 1 and 3 or just 2. So obviously the max is 4, but how do we get to 4? 4 is the max between 1 plus 3 and 2, where 2 is the maximum amount of money that we can rob from the previous house, house 2, and 1 plus 3 comes from the amount of money we rob from robbing houses 1 and 3. Now you might be wondering, why is this the case? Why do we even consider 2? Well, let's say we have the instance 1, 100, and 2. If we rob 1 and 2, that gives 3. But if we just rob house 2, it's 100. Just robbing that one house would give more money than robbing both houses, which is why we must consider the max amount of money from robbing the house previous to the previous one, or just from robbing the house previous to the current one. And that's the idea. For every single position, we get it by using this formula. It's the max of the current house plus the amount of money, the maximum amount of money that we can get from the house previous to the previous one, and the amount of money that we can rob from the previous house, right? So that's the idea. So let's extend it to 1. If we want 1, then it's simply the max, right, of 2 plus 1, and 2 is this 2, not this 2, it's this 2, plus 1, comma, 1 plus, or sorry, it's the max of 4, right, the previous house, plus 1, or sorry, comma, 1 plus 2. So that's the max of 4 and 3. So obviously that gives 4, which is how we got at the answer 4. So we'll program this up, and I hope it's clear. As we said, we're going to store an array called DP. DP is going to be an array of initially all zeros that tells us the most amount of money that we can rob from up to the ith house, where I is the index of the array. And there's some special edge cases here. If so we do for I in range of the length of nums. The edge case is that DP of 0, right? DP of 0. So if I is equal to 0, then DP of I is equal to nums of I, right? That's the very first house. And if I is equal to 1, then that simply means DP of I is equal to the max between the previous house, nums 0, and the current house, nums 1. So those are the 2 base cases. And from there, we build on top to get the overall solution. So otherwise, if it's not 1, elif, if it's not 0 or 1, then we're dealing with the general case. And the amount of money that we can steal, the maximum amount at that current house, the ith house, is going to be the max of the current house plus DP of I minus 2. That is the skipping 1 house rule, right? With the max amount of money that we can steal from the previous house, I minus 1. And that's the entire algorithm. Once we're done with this whole for loop, we simply return DP of length of nums minus 1. And we can run it to see if it works, which it does. So let's submit. And there we go. That's the solution.